All right, today we're going to look at absolute value and conversions, and we want you to be able to solve any absolute value equations and convert any units of measurement. We'll start with absolute value. Absolute value is defined as the distance away from zero on a number line. So if you have, and this is the symbol right here for absolute value, it's like 2 bars around a number. If we're doing absolute value of 7, that's the distance 7 is away from 0 on the number line. So if you got a number line, 7's over here, that distance is 7 units. So absolute value of 7 would be 7. Absolute value of negative 7, okay, so here's negative 7 on the number line, also has a distance of 7 away from 0. So absolute value of negative 7 is also positive 7. Distances are always positive. Whenever you're traveling somewhere, you never say you go a negative distance. Distance is always a positive number. Okay, so when solving expressions, the absolute value bars act kind of as a parentheses. You need to perform any operations inside the absolute value bars first. Okay, so they kind of act like parentheses in that you need to start with them, but you can't do everything the same with as if it was parentheses, as we'll look in the next one. So let's look at this first example here. We want to start evaluating this by starting inside these absolute value symbols. So looking inside there, we want to multiply before we subtract. Remember our PEMDAS we talked about. So this would be negative 15 minus 7. Okay, now we want to go through and subtract these two terms. So you got 1.4 plus absolute value of, if we subtract those, negative 22. Okay, now we want to perform the absolute value. So negative 22 is a distance of 22 away from 0. So that's going to equal 22. And now if we add that together, the answer is 23.4. So that's what that expression would equal. All right, let's try the next one here. The one right below it. We want to go through, simplify that one. Now notice here there's this negative sign outside. Now if absolute value truly acted like a parentheses, we'd be able to distribute. You can't distribute though with absolute value. The absolute value has to be simplified first before you can do anything else. So never distribute with absolute value signs. We want to start inside there, add those two numbers up. So if we add those two numbers up, that's 17. Okay, now we got to take the absolute value. Okay, absolute value of 17 is 17. 17 is 17 away from 0. Okay, so that's 17. But now this little negative sign that's outside of the absolute value sign continues with what we have. And now when we add these two numbers up, we get negative 10.2, or sorry, negative 10.8. And that would be the answer to this one. So never distribute with absolute value. And then make sure that you perform absolute value before you do anything else. All right, let's look at absolute value equation. So when solving an absolute value equation, we want to rewrite this as two different statements. Okay, so taking a look at this one, what would x have to be to make this true? Two numbers can make this true. Obviously 5 would. The absolute value of 5 is definitely going to equal 5. But also the opposite of that would also make it true, negative 5. Okay, because remember negative 5 is also a distance of 5 away from 0. So when you have one of these absolute value statements, what we're going to be doing is taking and saying whatever's in there is equal to 5, but also the opposite. Okay, so we're going to take whatever's inside, make it the opposite, set it equal to 5. And then if you solve that, like here we would divide by negative 1, we always get that other value. So the two values would be 5 and negative 5. The one place you got to make sure, just kind of watch out is if you have an absolute value equal to a negative. Okay, because if you're thinking about what could go in here, well, could negative absolute value of negative 3 equal negative 3? Well, no, this doesn't quite work because remember, absolute value of negative 3 is positive 3. That doesn't quite equal negative 3. So anytime you have absolute value equal to a negative, then we say it's no solution because there's not going to be anything that makes that true. So absolute value has to be equal to a positive number in order to solve it. All right, let's try some of these solving ones. So we want to here solve and figure out what is the solutions to this. Now remember, there's almost always, if we can solve it, there's going to be two solutions to this, because there's going to be one on each side of 0. Okay, so looking at this one, we can just solve b plus 15 equal to 3 to get one of those solutions, and that solves pretty easy. Minus 15, and we get negative 12. So one solution that makes this true is negative 12. The other solution, though, remember, we want to do now the opposite. What's the opposite of that? So we want to take the opposite of what's in here and put it equal to 3. So the opposite of what's in there would be negative b minus 15. You want to change all the signs in there and solve that one. So the b should become negative and the 15 should become negative. Now if we solve this out, looks like here we're going to have to plus 15. You get 18, and we still got that negative, so we got to divide by negative 1. And so the other answer would be negative 18. Negative 18 and negative 12, both these two numbers make this true. And you can always check by plugging back in. If you plug these two numbers back in, if we make this negative 12, that means we're going to have absolute value of 3 equal to 3, which is true. Okay, that one comes out true. If you put in the other one, negative 18. Negative 18 plus 15 is negative 3. Absolute value of 3 is also equal to 3. That also comes out true. So both our numbers check out. Okay, let's try another one. Solve this one for n. Now, whenever you start getting more stuff on the one side of the equals besides the absolute value, your first job is to get all the other numbers away from that. So let's minus 4 to the other side first. We want to get rid of that 4. So now we got absolute value of 3n plus 2 equals negative 4. Oh, okay. This is something we should kind of be thinking about. You got absolute value equal to a negative number. Can we have that? No, remember, distance needs to be positive. Anytime you get it where you got absolute value and this number is negative, that's going to be a no solution. We can't solve this one because absolute value is going to have to end up equaling a positive number. Okay, next one, again, we want to solve. So in order to tell if this is going to be a no solution problem or not, first thing we want to do is get all that other junk away from our absolute value here. So our 4, let's minus 4 to the other side. When we do that, now we got this. Whoop. That'd be 12. Okay, now we want to get that 3 to the other side. Now be careful here, we're not minusing 3. Okay, this is being multiplied here. And we don't want to necessarily distribute here either, because distributing is going to, we got the absolute value, it's not a parenthesis. So here we can divide both sides by 3 to get rid of the opposite of multiplying is dividing. So now you got x plus 5 equals 4. So now it's a positive number. We should be able to solve this. Solve x plus 5 equal to 4. That one's going to give you negative 1. So that's one answer. Now we want to do the opposite of what's in there equal to 4. So the opposite would be negative 5 minus 5. Switch the signs on everything in there. So now add 5 to the other side. You get 9. Divide by negative 1. And the other answer is negative 9. So both negative 1 and negative 9 are solutions there. Okay, so that's absolute value. We're going to keep working with that throughout this unit. The other thing we're going to look at today is conversions. Listed here are a bunch of common conversions that you should be aware of. The ones with time here, I think most of you are very comfortable with. The metric system, okay, that is used a lot in sciences here. 1 centimeter is the same as 10 millimeters. 1 meter is 100 centimeters. and 1 kilometer is 1,000. These little prefixes can help you kind of remember that kilo means 1,000, cent, like a century, is 100, milla here would be 10, sorry, centa would be 10 for that one. Okay, so then over on here, this is like the empirical units that US uses. They're not used a lot of other places in the world. The conversions are a little harder to remember because the numbers aren't like powers of 10. So 1 foot is 12 inches. 1 mile is 5,280 feet. That's kind of a difficult one to remember. And then 1 yard is 3 feet. All right, so let's try doing some of these conversions. How many seconds in 7 hours? When you are doing these, sometimes if you just kind of know how to do them, go ahead and do the multiplying or dividing. If you get stuck though, one way you can do this is always to write out what you start with and then multiply by the conversions. So this first thing, 7 hours, okay, we don't have, it's not like 7 hours over anything. So then you can just always put it over 1. Okay, now you always, everything after this first thing should be a conversion. So everything else we're going to multiply by should be one of these things up here. Okay, so if we're going to go from hours to seconds, we're probably going to have to go through this, through minutes here first to get there. So how many minutes in an hour? 60. Now, to do this, we want our units to cancel out. So if hours is on top here, we want our hours on bottom here, because anytime you are multiplying, you got something on top, something on bottom, they always cancel out. So 1 hour is the same as 60 minutes. That's this conversion we just wrote down. So now you can cancel out hours, and now our units are in minutes. But we got to get to seconds, it looks like. So now do the next one. 1 minute equals 60 seconds. Here, minutes are on top, so we want minutes on bottom here. So we got 1 minute, it's the same as 60 seconds. Okay, minutes now cancel out. So now if we multiply this out, we get our answer. Multiplying all the numbers on top, 7 times 60 times 60 would be 25,200 seconds. Okay, if you can just do that without writing this out, I'm fine with that. I'm just showing you a way. If you're starting to get confused, you can always use this little setup to help you do it. All right, how many yards is 198 inches? Okay, start with what you got here. This is what we got, 198 inches. And there's nothing else to this, so we can put it over 1. All right, so looking up here, we don't have a conversion of inches to yards, so we probably have to go through our middle thing of feet here. Okay, so we know that 1 yard equals 3 feet. We also know that 1 foot is 12 inches. So those two conversions should be able to get us to where we go. Okay, since we're starting in inches, we need this conversion with inches first. We got inches on top. So our other one here, we want inches on bottom. We got 12 inches in 1 foot. Anything after this first thing you write down here should be equal to each other. And 1 foot is the same as 12 inches. All right, so now we got to do another conversion here. We're not to yards yet. So now we know that 1 foot is, or 3 feet is 1 yard. So here we got feet on top. We want feet on bottom here. 3 of them is the same as 1 yard. Feet are gone, inches are gone. Our answer now should be in yards. So now if you're multiplying this out, whenever you multiply fractions, you multiply everything across the top, everything across the bottom. So here we got 198 on top. 1 times 12 times 3 is 36 on bottom. If you divide those out, you get 5.5 yards. So 198 inches is the same as 5.5 yards. All right, next one. This is now a rate. How fast are you traveling in miles per hour if your current speed is 50 feet per second? 50 feet per second is probably not something most of you can kind of just think about how fast that is, but a lot of you kind of have a judgment of miles per hour from maybe taking like driver's classes. So let's see if we can do this conversion. Start again with what you know. This is what we know. 50 feet per second means per 1 second here. We're going 50 feet every 1 second. Now after this, we want to do conversions, okay? So let's start with feet to miles. How many feet are in a mile? Well, from our last thing, we know it's 5,280. Okay, now notice feet are on top here, so when we're doing our conversion, we want feet on bottom here, and we know 5,280 of them are the same as 1 mile. Okay, so now we should be in miles like we want. Okay, but now we got to go from seconds to hours. Okay, so now we got to do some converting there. We can go through minutes here. So we know we got seconds on bottom. So now our next conversion, we want seconds on top. We know there's 60 of them in 1 minute. So now 60 cancels, or seconds cancel out. But we're still not to hours, so let's do our next one. We got minutes on bottom here. So we want minutes on top here. There's 60 of them in 1 hour. So now minutes are going to cancel. So now our answer should be in miles on top per hour on bottom. So now multiply like we did on the last one. If you multiply 50 times 1 times 60 times 60, that's going to give you 180,000. On bottom, multiply 1 times 5,280 times 1 times 1. That's just going to be 5,280. Now, if you divide these two numbers, it should give you the answer. It equals about 34.1 miles per hour. So now you got something that's a little more comprehensive. 50 feet per second is the same as about a driving speed, 34.1 miles per hour. Let's try one more of these ones. This one says a car speedometer says you are traveling 50 kilometers per hour. How fast are you traveling in meters per second? Start with what you know. This is what they gave us. So the first thing should always be what they gave you. 50 kilometers per every 1 hour. All right, so now convert. Okay, we got to go from a distance of kilometers to meters. If you're not sure, you can look back and cheat. 1 kilometer is 1,000 meters. Okay, so we got kilometers on top here means we want our conversion of kilometers here to meters. We know 1 kilometer is 1,000 of these. Okay, so now we should be in meters. Okay, but now we got to go from hours to seconds. So do that conversion. We got hours on bottom. So we want hours on top of our conversion here. We can go from hours to minutes. We know 1 hour is 60 minutes. So now hours are gone. But we got to get to seconds. So we got minutes on bottom means we want minutes on top here. And minutes and seconds, we know 1 minute is 60 seconds. So now our answer should be in meters per second. Okay, so do the multiplying. 50 times 1,000 times 1 times 1 is 50,000. Okay, on bottom we got 1 times 1 times 60 times 60. Well, 60 times 60 is 3,600. Divide these two numbers and you get about 13.8 meters per second. So that's how fast it would be driving. All right, you try some of these out now on your own on the practice.